Okay, please look at your notes on inverses. And it says that the inverse interchanges the input and output values. What's an input value? The number you put in, right? And that is usually the X values. Next to the word input, write X. So if X is the input value, what's going to be the output value? And what does this word right here mean? Interchange. If I look that up in a thesaurus, what would be another word for it? I hear some people whispering it. Yes, that would mean switch. So what this is telling me is to get an inverse, you switch the X and the Y. So would you write that at the top of your paper, because that is very important. All you have to do to get an inverse is switch the X and the Y. It doesn't matter whether you're in an Algebra 1 class or an Algebra 2 class, or you're doing trig functions in pre-cal, or you're doing some rational function in calculus. It's still the same process. To get an inverse, you switch the X and the Y. Might be a little harder to do that if the function's a little more complicated, but it's still the same process. If you switch the X and the Y, what's that going to do to the domain and range? Do you remember what the domain goes with? X. And the range goes with Y. So if you switch the X and the Y, what are you going to do with the domain and range? You're going to interchange or switch those also. Can you remember back to geometry? Toward the end of the year in geometry, did you do reflections over the x-axis and reflections over the y-axis? Do you remember doing reflections over the y equals x line? That's a line that goes diagonally across your graph paper. Did y'all do those in geometry? That, when you did those in geometry, you made an inverse. So in all of our math classes, inverse is the same. Switch the X and the Y values. So down here in problem number 1, how do you find the inverse? It's that easy. Switch the X and the Y values. It's that easy if you have simple points. On 1B, can you find the inverse then? Switch the X and the Y values. What's amazing is people sometimes miss this on a test because they can't believe it's that easy. Yes, it's that easy. If you have a point, all you have to do to find the inverse is switch the X and the Y values. If you have a table, what are you going to do to find the inverse? You think you could do that? I'm going to switch the X and the Y values. This table is an inverse of the first table. Would you please take a moment and graph those points on your graph paper? The inverse of a line is another line. The first line and the inverse line are reflections over the y equals x line. This line right here is the y equals x line. If you fold your graph paper on that dotted line, if you fold your graph paper on that dotted line, this line will match up with that line. That's what it means that this is the line of reflection. These are reflections over this y equals x line. Can we write the equation of the inverse line? Can we write the equation of this line right here? If we're writing the equation of this line right here, if it's a line, it's in y equals mx plus b form. Right? Do we remember what that stands for? What does the m stand for? Angel, what does the m stand for? Would you please answer me? The m stands for the slope, so we're going to do rise over run. So, Alex, did you get a rise over run? Do you know how much that is? This red line right here, is that going to be a positive line, a positive 1/2 or a negative 1/2? That line right there is going up, so it's a positive 1/2. Do you remember what the B stands for? Y-intercept. The y-intercept is this number right here. What is the value of this number right here? This is the inverse of the line we started with. The line we started with over here is written in function notation. The function notation for an inverse looks like this, except to show that it's an inverse, we put what looks like a little exponent -1 right here, and this is the function notation symbol for inverse. If the function notation has what looks like a little -1 exponent, that's the symbol for an inverse. We got all that? Okay, so down here in example number 3, if you have a table, what are you going to do to find the inverse? Xavier, what are you going to do to find the inverse? Switch the x and y. Melissa, what are you going to do to find the inverse? Switch the x and y. Alexandra, what are you going to do to find the inverse? And so when you have those switched, would you take a moment to put those on your graph? If you graph this table and put it on the graph paper, does it make a line? No. The original graph, do you remember what that's called? Is a parabola, so guess what the inverse is? It's also a parabola. This inverse, this parabola points up, this parabola points to the right. If you folded it on this y equals x line, if you folded your graph paper on this line, these two parabolas would match up. Now, we have one more question here. Is this inverse right here, is it a function? What's a function? Well, the very first lesson we had when we came back from the holidays was on function notation, and the very first thing on that notes was the definition of a function. I'm sure you all remember. Or maybe you forgot. So, and that definition is a little bit hard to understand, so we're going to look at this definition. A function has no repeated x values. Look at this x column right here. Do any of these numbers repeat? No. And so this goes with this parabola. This parabola over here is a function because it has no repeated x values. Look at this other table. Do you have a repeated x value? You have more than one, but at least one. Do you see that the x value is repeated? That means that this is not a function. This one right here is not a function because it has repeated x values. It's pretty easy to tell a function from a table. Problem number 3 says solve algebraically for g of x. Please mark out the g of x and actually write in the word inverse to make it very clear that what we're solving for is the inverse. Okay, so on your notes, what did you write down? How do you solve for an inverse? Switch. What? X and Y. Does this equation right here even have a Y? No, but do you know that this stands for Y? I could take this out and replace it with a Y. Isn't y equals the same as f of x equals? Now does it have a y? Guess what I'm going to do with the x and y? To find the inverse, you switch the x and the y and solve for the y. That's the hard part. To solve for the y, solving for this y right here, what am I going to do with this 6? The opposite of add 6 is subtract 6. If I subtract 6 on the right-hand side of the equation, what do I do on the left-hand side of the equation? So that will cancel. I am solving for y. What am I going to do with the 3/4? You want to do this in one step or two? If you want to cancel out the 3/4 in one step, what is the reciprocal of 3/4? The reciprocal, not the decimal, the reciprocal of 3/4 is 4/3. And if I multiply this side of the equation by 4/3, what do I have to do on the other side? Now, the reason you multiply by 4/3 is so that the 4's cancel and the 3's cancel. And over here, you have to distribute. And so that's going to be 4/3 x. When you multiply 4/3 times 6, 4 times 6 is 24. 24 divided by 3 is 8. You can do that with your calculator. That is the inverse. Y is equal to 4/3 x minus 8. Over here at the top of this paper, I am going to take out that notation. That was a typographical error. The inverse is written in function notation with a little, looks like a -1 exponent. This is the way to show that this is an inverse of this equation that we started with. Once again, in order to find an inverse of a table, what do you have to do to find the inverse of a table? An inverse of a table is pretty easy. You just switch the x and the y. But when you have an equation, you can also find the inverse from algebra. But you always find the inverse the same way, switching the x and the y. So the first thing I need to do is change this to y equals notation. The y equals is the same as the f of x equals. And then to find the inverse, you switch the x and the y. So this would be x equals 1/2 y plus 4 parentheses squared minus 3. And I need to solve that for y. If I'm solving that for y, the first thing I'm going to do is the 3. That's a minus 3. What am I going to do to get rid of a negative 3? I'm going to add 3 to both sides of my equation so that that will cancel. Am I going to distribute the 1/2 into the parentheses next? No. Do not distribute a number into a parentheses where the parentheses is squared. You cannot distribute the 1/2 into the parentheses because the parentheses is squared. So what's another way to get rid of a 1/2? The reciprocal of 1/2 is 2/1. If I multiply this side by 2/1, what do I need to multiply this side by? So that the fraction will cancel. Distribute the 2. Because 2/1 is the same as 2. 2x plus 6. Y plus 4 parentheses squared. Now, I don't want to square that out and make this thing more complicated. I want to get rid of the square. What's the opposite of a square? Do we know that? A square root cancels out a square. The square and the square root cancel each other out. Now, we talked about this when we did square roots before, but it's been a long time. When you take a square root to solve an equation, it is plus or minus the square root. We're going to learn a little bit more about why when we get to the graphing of square roots. So this is going to be plus or minus the square root of 2x plus 6. I'm almost finished. I've almost solved for y. What do I need to do with the 4? It's a good thing. I'm almost out of paper. So this cancels out. You can't subtract the negative 4 from the 2 because this has an x. They're not like terms. I also cannot subtract the negative 4 from the 6 because the 6 is under the radical and the 4 is not. The 6 is under the square root sign and the 4 is not. They are not like terms. So this is minus 4 plus or minus 2x plus 6. We put the minus 4 out in front so it's very clear that the minus 4 is not part of the square root sign. So that is the inverse. I'm going to rewrite that over here. In this blank, I'm going to use my function notation, the inverse is -4 plus or minus the square root of 2x plus 6, where the 2x plus 6 is underneath the radical sign. Would you please complete problem number 9 at this time? This is the correct answer for problem number 9. If you got this one right, please continue on with your homework.